Alright, so this is covering 7H, key features of periodic functions. Check the announcements, make sure that you know your due dates, deadlines, all that good stuff. Alright, now this comes with a lot of vocabulary. Alright, this part of the section isn't terribly difficult, but it's very formula specific and it's very vocabulary specific. Alright, so a periodic function is a function that repeats after a specific interval. Alright, so these graphs are periodic because they make these waves that just keep repeating themselves forever and ever and ever. Okay? The period is the distance that the function takes to repeat. Right? The midline is the halfway point between the minimum and the maximum. And the amplitude is the distance from that midline to either the maximum or the minimum. That's the amplitude. And the frequency is the reciprocal of the period. When you think about frequency, think about radio frequencies. All right, that's kind of where this comes from. Okay, so if these were modeling sound waves, the frequency, which is how they determine, like, I don't know, where it is on the radio or whatever, that comes from this. Neat. Alright, so the sine and cosine, right, this is their kind of parent function form. Okay, notice that there's b's here, alright? Now the interesting part of this is a lot of these things are very similar to transformations that we've seen before. They're just different words. Okay? But this b is what's factored out of the parentheses here. We saw that a bit with exponentials, didn't we? Not exponentials, radicals. Alright, so let's try this out. So let's label some of this stuff, okay? I'm trying to show you on the graph where each of these are. Now there's 5 anchor points that we usually care about, okay? So for the sine, our anchor points are where they cross the x-axis, and then your minimum and your maximum. Okay? This is one period of the function. So right here, I'm going to call that period. Okay? The midline is the halfway point between the minimum and the maximum, right? So I'm going to draw a couple of lines here to help us see things. So this here is the minimum. This here is the maximum. Because we like the letter M, this here is the midline. It usually starts out at y equals 0. That's kind of its default position, but that might change. Alright, now the amplitude, I'll do it in red, I guess. The amplitude is the distance from the midline to either that minimum or maximum. The amplitude must be positive. Alright, so there's that one. Okay, I think I labeled everything. Yeah. Okay, let's check for cosine. Now the cosine graph, because I only have one iteration of it on here, doesn't look like it, but it looks very similar to the sine graph. You're going to see later on that you're going to have a hard time telling between the kind of sine and the cosine, and that's because the cosine is just a slight shift to the side from the sine. So these are your 5 anchor points, all right? So this is one period. Oh, I wanted to mention, this is going from 0 until 2 pi. So traditionally, the period is usually 2 pi. Divided by our b value, Your b value here is usually 1, so yeah, we're good. So your period in this case, 2 pi. Okay, so if I draw in our little lines, right? This here's the maximum. This here's the minimum. And halfway between the two is the midline, which on this one is currently y equals 0. But if you have a vertical translation, right, that'll change that. And then if I label my amplitudes, these are both the amplitude. Traditionally, the amplitude is only 1, right? If it's on a unit circle, it comes up to here, which is 1. All right, so let's check out some graphs. We're going to talk about it. All right, so the minimum, if I draw this line here, right, see how it comes down this low? So the minimum is at y equals -1. Our maximum, our highest point, is at y equals +1. Our domain on these is always the same. All right, this graph is going to keep going woo, 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 for forever and ever, to the left and to the right. So our domain goes from -infinity to infinity. And our range, unless we have a vertical stretch, always goes from -1 to 1. And remember, if you're using whole numbers here, you're usually inclusive, in this case specifically. So you got to use your little square brackets on those. Let's try it again. So this one has a minimum. Ooh, it changed from -1. This one's all the way down at -3. And this one came up to +3. Your min and max don't always match because you can have vertical shifts. But if it's symmetrical across this x-axis, then, not symmetrical, but centered around this x-axis, these will usually have just opposite signs. So your domain, right, this graph goes left for forever, and it goes to the right for forever, so that's -infinity to infinity. And your range just goes from the minimum to the maximum. Now's the fun part. All right, now here we're seeing it without a graph. Now the domain, I know that one, okay? The domain's good. Everything else is a little... Okay, so the way that we're going to figure this out is we're focusing on this piece here, okay? This moves your midline. And this piece here, which is a stretch. Okay, so if I'm thinking graphically, I'm just doing a little itty bitty sketch. So I'm going to move this up here. Okay, I'm going to go down to -7. I have a little curve coming here, okay? That's my new midline around that curve. Now with an amplitude of 5, I was using red for amplitude. I'm going to change that to red. But with an amplitude of 5, what this is saying is that from that midline to the top and to the bottom, there's a distance of 5 on each of those. So if I'm at -7 and I come 5 up, that would put me at -2. And if I'm at -7 and I go 5 down, that puts me at -12. So my new minimum is -12, and my new maximum is -2. So my range is now from -12 to -2. And again, that came from shifting down your midline, and then you use your amplitude to figure out how far up, how far down. Let's do it again, okay? So my midline, oh gross, this amplitude is a 1/3. Miss Caswell doesn't like adding fractions. That's gross. Oops. It's going to move down by 2 units. So here's your new midline. Alright, and this graph is going to go woo, 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 woo. Okay. Not being super specific on it, I just know it's going to bounce like that. And that means that I'm going to have a new maximum and a new minimum. Now, because this is talking about thirds, I want to talk about this as thirds. Okay, because that'll make it easier to add my fractions. So if I want that in thirds, a number divided by 3 that'll equal -2 is 6. Okay, so I'm just going to call that midline -6/3. Okay, so if I go up by 1/3 from -6/3, that'll put me at -5/3. And if I go down by 1/3, that would put me at -7/3. So my minimum is -7/3. My maximum is -5/3. So our range is -7/3 to -5/3. The domain's happy. The domain's the same thing every time. But messing with that amplitude to figure out the amplitude and midline, I should say, to figure out your minimum and maximum kind of sucks. I really like this question. Big fan of it. Just so you know. Huge fan. So we have a hawk population over a 5-year period, and they give us this function. They want us to figure out the range, and they want us to know why it's periodic. Okay, so I'm just going to do this kind of same process. Okay, now this one goes up 300, right? So that's the change in your midline. Okay, so I know my little 0 line should go here. And at 300, that's my midline. So the graph's going to go woo, 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 woo. We'll learn more about those woos in another section. But for now, that's where we're at, okay? And our amplitude is 100. So that's saying that on this 300, if I go up by 100, I'll reach my maximum. And that up by 100 would put me at 400. And to get my minimum, I would go down by that 100, which would put me at 200. So to answer this, my range would be from 200 to 400. Now let's talk about the Y piece. I'll write it in purple, I guess. Well, let's think about what would cause a population to fluctuate like this, to grow and shrink and grow and shrink and grow and shrink, right? During the growth portion, it could be based off seasonal, right? Don't you hear about like mating season with birds in like the spring, or really with any animal in the spring? Their populations tend to increase, right? There's an increase in food availability because of the season. Okay? And then they would decrease in the fall and the winter as food becomes more scarce. All right? So that's an idea there about why it's periodic. Okay, so I'm going to say maybe it could be periodic based on seasons and food availability. Okay, so now here we are with a rabbit population. All right, it's going to look very, very similar. It's going to be just about the same process. So what I'd like you guys to do is I'd like you to pause the video for just a second, and I want you guys to see if, see if you could figure it out on your own for a second. Okay, so hopefully you did pause. Hopefully you listened to me. All right, this here's your midline. This here's your amplitude. Okay, so if I'm thinking about a graph, right, that 2100, that midline, is moving up by 2100. All right, so then I'm going to draw my little woo, 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 woo. Okay. Now the amplitude says from that 2100, I'm going up by 450. So that would put me at 2550. It says I'm going down by 450, which I don't know off the top of my head. I'm just using my calculator. Sorry, guys. So 2100 minus 450. That's 1650. So sometimes those numbers can be a little ick, yeah? Okay, so my range it's at 1650 in the bottom. That's my minimum. And it goes to 2550 in the top. That's my maximum. Okay, so now that I've done that part, let's see. So now let's look at the y here. Okay. Again, that y for the rabbit population, it could be seasonal. That's what my usual thing is. Okay. It's cyclical. Ooh, I don't know how to spell cyclical. Good job, schedule. Because of food availability. Okay, so there we are. Those are those kind of key features here. All right. I believe in 7i we'll touch on period and frequency a little bit more. This part was just mostly focusing on the amplitude and the midline in your domain and range.